Now, in this lecture, we find out the distance between the centers of two circles. In the drawing, we have rectangle ABCD. We know that side AB of this rectangle equals to 7 units in its length. Side BC equals to 24 units in its length. In addition, we know that the center of this circle is here at point Q. The center of this circle is here at point P. Our mission is to find out the distance between the centers of those two circles, that is to say, the length of line segment QP. Okay, so first of all, because of the fact that ABCD is a rectangle, it means that those four angles are all right angles. So, I'll write it down. This angle equals to 90 degrees. This angle also equals to 90 degrees. This angle equals to 90 degrees. And finally, this angle also equals to 90 degrees in size. And we also note that the opposite sides of a rectangle are equal to each other. That is to say, side AB equals to side DC. But AB is 7, therefore side DC must be also equal to 7 units in its length. Likewise, in rectangle ABCD, side BC must be equal to the opposite side AD. But BC is 24, therefore AD must be also equal to 24 units in its length. So this angle ABC equals to 90 degrees, therefore we can implement the Pythagoras theorem of the right triangle ABC. So according to the Pythagoras theorem, the right triangle ABC by PT is a progression for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 7, therefore AB squared is 7 squared, that is 49, plus BC squared. BC is 24, therefore BC squared is 24 squared, that is 576. So we found out that AC squared in total, it is equals to 49 plus 576 is 625. Here we take a root out of this equation and we get that AC equals to the square root of 625, that is actually 25 units. So we actually found out that the length of the hypotenuse AC in the right triangle ABC is equals to 25 units in its length. So we have here this circle is blocked by the right triangle ABC, and this circle is also blocked by the right triangle CDA. So both those two circles are blocked by a right triangle. Therefore, we will develop a general equation or a general formula that will help us to find out the radius of any circle that is blocked by a right triangle. So here we have the right triangle ABC. This right triangle ABC blocks the circle. We know that the radius of this circle is x. In the next step, we will develop a formula that will help us to find out the length of the radius of this circle, that is x, only by knowing the side lengths of the right triangle ABC that blocks the circle. Okay, so we define the point of tendency BC with this circle as M. OM is the radius of this circle. The radius OM is drawn to point M, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. I remind you, what is rule number 1? According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 1. Okay. We define the point of tendency of tangent AB with this circle as N. In the next step, we join points O and N together by straight line. ON is the radius of this circle that is equal to X. According to our definition, the radius ON is drawn to point N, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees. And this angle equals to 90 degrees according to rule number 1. So inside quadrangle NBMO we have 1, 2 third angles, therefore the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. In order to complete the sum of the angles in this quadrangle to 360 degrees, the missing angle must be equal to 90 degrees. So inside quadrangle NOMB we have 4 right angles, therefore can relate to this quadrangle NOMB is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say OM equals to NB. But OM is X, therefore NB must be also equal to X. Likewise, in the same rectangle, NO equals to BM. But NO is X, therefore BM must be also equal to X. So actually found out that quadrangle NOMB is not a rectangle but a square because all of its sides are equal to each other, each side equals to X. Okay, so what is the length of line segment AN? From the drawing it is very easy to see that AN equals to AB minus NB. Again, AB minus NB equals to AM. Equals to AN. So AN equals to AB, that is A, minus NB, that is X. So in total AN equals to A minus X. Likewise, from the drawing it is very easy to see that the length of line segment CM equals to CB minus MB. Again, CM equals to CB minus MB. CB is B and MB is X, so in total CM equals to B minus X. So here MC or CM equals to B minus X. Then we have here rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point, point P. From the common external point, point P, we have two tangents to the circle, tangent PA and tangent PB. And according to this rule number 2, they must be equal to each other. That is to say, PA equals to PB. So we can actually implement rule number 2 in our drawing. One, because in our drawing, we have the common external point, point A. From the common external point, point A, we have two tangents to the circle, tangent AN, and this tangent, we define the point of tendency of tangent AC with this circle as S. So, from the common external point, point A, we have two tangents to the circle, tangent AN and tangent AS. And according to rule number 2, they must be equal to each other. That is to say, AN equals to AS. But AN is A minus X, therefore AS must be also equal to A minus X. Likewise, we will focus on the common external point, point C. From the common external point, point C, we have two tangents to this circle, tangent CM and tangent CS. And according to rule number 2, they must be equal to each other. That is to say, CM equals to CS. but cm is b minus x, therefore cs must be also equal to b minus x. I repeat again that the length of side AB is A units, side BC equals to B units in its length, and the length of the hypotenuse AC is C. So the hypotenuse AC is equal to C units in its length. AC also equals to AS plus SC. So you can write here that AC, that is actually C, equals to AS plus SC. So C equals to AS, that is A minus X, plus SC, that is B minus X. So in total, C equals to A plus B minus 2X. We will add 2X to this equation and we get that C plus 2X equals to A plus B. We subtract C from this equation and we get that 2X equals to A plus B minus C. We divide this equation by 2 and we get finally that X equals to A plus B minus C over 2. So actually we found out the general formula to find out the radius of this circle that is X according to our definition only by knowing the side lengths of this right triangle, triangle ABC that blocks this circle. That is to say the radius X must be equal to A plus B minus C over 2. Repeat again, the radius of this circle that is equal to X, it must be equal to A plus B minus C over 2. We can implement the new formula in order to find out the radius of this circle. The radius of this circle that is blocked by the right triangle, triangle ABC. We define the radius of this circle as R. So the radius of this circle R that is blocked by the right triangle, triangle ABC, according to the new formula, must be equal to AB plus BC minus the length of the hypotenuse that is AC over 2. I'll repeat again. The radius of this circle that we defined as R, that is blocked by the right triangle, triangle ABC, must be equal to AB plus BC minus AC over 2. AB is 7 plus BC that is 24 minus AC that is 25 over 2. 7 plus 24 is 31, 31 minus 24 over 2. 31 minus 24 is 6 and 6 over 2 is 3. So finally we found out that the radius of this circle that is blocked by the right triangle ABC equals to 3 units. Likewise, we use the same formula in order to find out the radius of this circle that is blocked by the right triangle CDA. We define the radius of this circle as X. According to the new formula, the radius of this circle X that is blocked by the right triangle ACD must be equal to ACD plus DA minus CA over 2. Repeat again, the radius of this circle that is X that is blocked by the right triangle CDA must be equal to CD plus DA minus CA over 2. CD is 7 plus DA that is 24 minus CA that is 25 over 2. 7 plus 24 is 31, 31 minus 25 over 2. 31 minus 25 is 6 and 6 over 2 is 3. So finally we found out that the radius of this circle X it is equal to 3 units in its length. So here we'll implement the rule number 1. Here we define the point of tendency of tangent BC with this circle as M. PM is the radius of the circle. The radius PM is drawn to point M, that is the point of tendency of tangent BC with the circle, and whenever a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MP. That is to say, this angle must be equal to 90 degrees, and this angle must be also equal to 90 degrees according to rule number 1. This angle equals to 90 degrees because ABCD is a rectangle. We will define the point of tendency of tangent AB with this circle as N. In the next step, we join points P and N together by a straight line. Pn is the radius of this circle is equal to 3. The radius Pn is drawn to point N, that is the point of tendency of tangent AB with this circle. Whenever a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NP. If AB is perpendicular to NP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. So inside quadrilateral NPBM, we have 1, 2, 3 angles, therefore the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral NPBM, we have 4 angles, therefore we can relate to this quadrilateral NPBM as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, PM equals to NB, but PM is 3, therefore NB must be also equal to 3. Likewise, according to the same rule, NP must be equal to PM. But NP is 3, therefore PM must be also equal to 3 units in its length. So we actually found out that quadrilateral NP, this quadrilateral NPBM is not a rectangle but a square. Why? Because all of its sides are equal to each other. Each side is equal to 3 units in its length. We can repeat all the same process here, and we get that this quadrilateral will be also a square with one side that is equal to 3 units. It will be exactly the same process. Here we define the point of tendency of tangent AD with this circle as G. According to rule number 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the point of tendency of tangent DC with this circle as K. We join points Q and K together by a straight line. QK is the radius of this circle that is drawn to point K, therefore this angle equals to 90 degrees. And this angle equals to 90 degrees according to rule number 1. We have in the quadrilateral QKGD, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So in quadrilateral QKDG, we have 4 angles, therefore we can relate to this quadrilateral as a rectangle. We know that the opposite sides of a rectangle are equal to each other, that is to say QG equals to KD. But QG is 3, therefore KD must be also equal to 3. Likewise, according to the same rule, KQ equals to DG. But KQ is 3, therefore DG must be also equal to 3 units in its length. So again, quadrilateral QKDG is a square because of the fact that all of its sides are equal to each other, each side equal to 3 units. Okay. So we have here 2 squares, each side of this, those 2 squares is equal to 3 units in its length. In the next step, we will extend the radius QG by straight line until it touches side BC of the rectangle. And we define the extended side GQ with side BC as point T. QG is a radius, it is absolutely a straight line. We extended the straight line QG by a straight line, and we got line segment GT. That must be also straight line, because when you extend a straight line by straight line, the result must be a straight line. So GT is a straight line. Here, in this way, we created quadrilateral TCDG. In this quadrilateral TCDG, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral DGCT, we have 1, 2, 3 right angles, and therefore the fourth angle, as I already mentioned before, must be also equal to 90 degrees. Therefore, inside quadrilateral GDCT, we have 4 right angles. Therefore, we can relate to this quadrilateral GDCT is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, GD equals to TC, but GD is 3, therefore TC must be also equal to 3 units in its length. Likewise, in the rectangle GDCT, side DC equals to side GT. But DC is 7, therefore GT must be also equal to 7 units in its length. So side GT equals to 7 units in its length. According to the rule that the opposite sides of a rectangle are equal to each other. In the next step, we will extend the radius NP of this circle by straight line until it touches side DC of this rectangle. And we will define the touching point of the extended radius NP inside DC as point H. So, in this way, we created quadrilateral HCBN. In this quadrilateral HCBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. So, inside quadrilateral NHCB, we have 4 right angles. Therefore, quadrilateral NHCB is a rectangle. And you also know that the opposite sides of a rectangle are equal to each other. That is to say, NB equals to HC. But NB is 3, therefore HC must be also equal to 3. Likewise, according to the same rule, side BC of rectangle BC and N must be equal to side NH. But BC is 24, therefore NH must be also equal to 24 units in its length. We define the intersection point here as point Y. So in quadrilateral YHCT, we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees. So quadrilateral YHCT has 4 right angles, therefore we can relate to this quadrilateral as a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, side HC equals to side YT, but HC is 3, therefore YT must be also equal to 3. Likewise, according to the same rule, in rectangle YHCT, side TC must be equal to side YH, but TC is 3, therefore YH must be also equal to 3 units in its length. We have already found out that GT equals to 7 units. GT equals to 7 units. So GT minus GQ minus YT. So GT minus GQ minus YT equals to the missing side, that is QY. Okay. Again, GT minus GQ minus YT equals to the missing side, that is QY. So GT is 7 minus GQ, that is 3, minus YT, that is 3, must be equal to the missing side, QY. So QY equals to 7 minus 3 minus 3, that is 1. So we have already found out that n edge equals to 24. N edge equals to 24. N edge is one straight line, and it is equal to 24 units in its length. So n edge minus np minus y edge, again n edge that is 24 minus np that is 3 minus y edge that is also 3 must be equal to the missing side, that is actually side py. So in total py equals to 24 minus np that is 3 minus y edge that is also 3. So py in total equals to 24 minus 3 minus 3, that is 18. So py equals to 18 units in its length. And we already found out that qy equals to 1. So here this angle equals to 90 degrees. GT is one straight line. If we focus on this side of the straight line GT at point Q, which angles we have? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. Therefore the missing side here must be equal to 90 degrees. Likewise, according to the same rule, if we focus on this side of the straight line GT at point Y, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees. In the next step we focus on the upper side of the straight line n edge at point Y. At the upper side of n edge at point Y, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of n edge at point Y? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees. So the missing angle must be equal to 90 degrees. So actually triangle QYP is a right triangle because angle QYP equals to 90 degrees. So in the next step we will implement the Pythagoras theorem on the right ring triangle, triangle QPY. So I'll copy the right ring triangle QPY in a new page and we'll implement on this right ring triangle, triangle QPY, the Pythagoras theorem. My PT is a relation for Pythagoras theorem. So actually, this is the right ring triangle, triangle QPY that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle PQY, PQ squared equals to QY squared plus PY squared. Okay. So PQ squared equals to QY squared. QY is 1, therefore QY squared is 1 squared, that is 1, plus PY squared. PY is 18, therefore PY squared is 18 squared, that is 324. So if we're going to find out that PQ squared equals to 324 plus 1 is 325. We take a root out of this equation and we get that PQ equals to the square root of 325. But 325 is 25 times 13. We take 25 out of this root and we get that the square root of 25 is 5. Inside the root we left only with 13. In conclusion, we found out that the length of the hypotenuse QP is equal to either 5 times root of 13 units, or in terms of numbers, it is equal to 18.03 units. And that is the answer to our question. Repeat again. The distance between the centers of those two circles, that is to say the length of this line segment QP, equals to either 5 times root of 13 units, so in terms of numbers it is equal to 18.03 units. It is a little bit greater than 18 units. Okay, so in the next step I'll summarize the lecture. So in this lecture we found out the distance between the centers of those two circles, that is to say the length of this line segment QP. Q is the center of this circle and P is the center of this circle, and the distance between the centers is QP. We found out the length of this line segment QP. In the drawing we have rectangle ABCD. And because of the fact that ABCD is a rectangle, it means that all those four angles must be right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to DC, but AB is 7, therefore DC must be also equal to 7 units in its length. Likewise, side AD of rectangle ABCD must be equal to side BC. But BC is 24, therefore AD must be also equal to 24 units in its length. Then we focused on the right triangle ABC. On this right triangle ABC, implemented the Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ABC, AC square equals to AB square plus BC square. I repeat again. In the right triangle ABC, by PT is the operation for Pythagoras theorem. So AC square equals to AB square plus BC square. AC square equals to AB square. AB is 7, therefore AB square is 7 squared, that is 49. Plus BC square. BC is 24, therefore BC square is 24 squared, that is 576. So in total AC square equals to 49 plus 576, that is 625. We took a root out of this equation. And finally found out that AC equals to the square root of 625, that is actually 25. And the length of the opposite AC in the right triangle ABC is 25 units. Then we developed a general formula that will allow us to find out the radius of any circle that is blocked by a right triangle. This circle is blocked by the right triangle ABC, and this circle is also blocked by the right triangle CDA. So here we have the right triangle ABC. This again equals to 90 degrees, therefore triangle ABC is the right triangle. The right triangle ABC blocks this circle. According to our definition, the radius of this circle OM is X. So we developed a new formula that will help us to find out the radius of this circle that is X only by knowing the side lengths of this right triangle ABC that blocks this circle. Okay, it is according to our definition, the length of side AB of triangle ABC is A, side BC equals to B units in its length, and the length of the hypotenuse AC of this right triangle ABC is C units. We define the point of tendency of tangent BC with this circle as M. OM is the radius of this circle that is equal to X. The radius OM is on to point M, that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is on to a point of tendency, Then according to rule number 1, tangent BC will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. This angle equals to 90 degrees because of the fact that triangle ABC is a right angle. We define the point of tendency of tangent AB with this circle as N. We join points O and N together by side line. ON is the radius of this circle that is equal to X. The radius ON is drawn to point N, that is the point of tendency of tangent AB with this circle. And whenever a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So inside quadrilateral ON BM we have 1, 2 right angles, therefore the fourth angle must be equal to 90 degrees. So inside quadrilateral NOBM we have 4 right angles, and therefore we can relate to this quadrilateral NOBM as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, OM equals to NB, but OM is X, therefore NB must be also equal to X according to the same rule. NO must be equal to BM, but NO is X, therefore BM must be also equal to X. So I actually found out that quadrilateral NOBM is not a rectangle but a square. Why? Because all of its sides are equal to each other, each side equals to X. So what is the length of line segment AN? From the drawing it is very easy to see that AN equals to AB minus NB. Again, AB minus NB equals to AN. So AN equals to AB, that is A, minus minus NB, that is X. So in total, AN equals to A minus X. Likewise, we found out the length of this line segment MC. From the drawing it is very easy to see that MC equals to BC minus BM. So MC equals to BC, that is B, minus BM, that is X. So in total, MC equals to B minus X. So we actually found out in conclusion that MC equals to B minus X and AN equals to A minus X. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common standpoint to a circle are equal. We have the common standpoint point A, from the common standpoint we have the common standpoint point P, from the common standpoint point P we have two tangents to the circle, tangent PA and tangent PB. And according to this rule number 2, they must be equal to each other. That is to say, PA equals to PB. So we can implement rule number 2 in our drawing. Why? Because in our drawing we have the common standpoint point A. From the common standpoint point A we have two tangents to the circle, tangent AN and tangent AS. And they must be equal to each other. That is according to rule number 2. That is to say, AN equals to AS. But AN is A minus X, therefore AS must be also equal to A minus X. Likewise, according to the same rule, if we focus on the common standpoint point C, from the common standpoint point C we have two tangents to the circle, tangent CM and tangent CS. And according to rule number 2, they must be equal to each other. That is to say, CM equals to CS. But CM is B minus X, therefore CS must be also equal to B minus X. So, according to our definition, the length of the hypotenuse AC is C, but C, the hypotenuse AC also equals to AS plus SC. So we can write down here that C equals to also to AS plus SC. So C equals to AS, that is A minus X, plus SC, that is B minus X. So in total, C equals to A minus X plus B minus X. That is to say, C equals to A plus B minus X is minus 2X. So in total, C equals to A plus B minus 2X. We added 2X to this equation. We found out that C plus 2X equals to A plus B. We subtracted C from this equation. We found out that 2X equals to A plus B minus C. Then we divided this equation by 2 and found out that X equals to A plus B minus C over 2. So here we found a general formula to find out the radius of any circle that is blocked by the right triangle ABC only by knowing the side lengths of this right triangle ABC. That is to say, the radius X here must be equal to A plus B minus C over 2. We can implement the new formula in our drawing. Why? Because in our drawing we have this circle that is blocked by the right we have this circle that is blocked by the right triangle ABC. So the radius, according to the new formula, the radius of this circle that is R must be equal to AB plus BC minus AC over 2. Repeat again. According to the new formula, the radius of the circle R must be equal to AB plus BC minus AC over 2. AB is 7, BC is 24, and AC is 25 over 2. 7 plus 24 is 31, 31 minus 25 is 6, and 6 over 2 is 3. So I found out finally that the radius of this circle R equals to 3 units. We implemented the new formula also to find out the radius of this circle. According to the new formula, the radius of this circle that is blocked by the right angle CDA must be equal to, so here x, the radius of this circle is x. According to the definition, x equals to CD plus DA minus CA over 2. Repeat again, the radius x of this circle must be equal to CD plus DA minus CA over 2. CD is 7, DA is 24, and CA is 25. 7 plus 24 is 31, 31 minus 25 is 6, and 6 over 2 is 3. So I found out that the radius of this circle x also equals to 3 units in its length. Then we implemented here rule number 1. Point P is the center of the circle, point M is the point of the circle itself, therefore PM is the radius of this circle that is drawn to point M. Therefore, according to rule number 1, this angle equals 90 degrees and this angle equals 90 degrees. We join points P and N together by straight line. PM is the radius of this circle that is drawn to point N. Therefore, according to rule number 1, this angle equals 90 degrees and this angle equals 90 degrees. So inside quadrangle NB MP we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees. So inside quadrangle there are PNBM, we have 4 right angles, therefore can relate to this quadrangle PNBM is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other, that is to say NP equals to BM, but NP is 3, therefore BM must be also equal to 3. Likewise, according to the same rule, NB equals to PM, but PM is 3, therefore NB must be also equal to 3 units in its length. So found out that quadrangle NPBM is not a rectangle but a square. Why? Because all of its sides are equal to each other, its size equals to 3. We can repeat on the same process here. It is exactly the same process, and we get that GDQK is also a square, and each side of this square equals to 3 units. So those two shapes are both squares. Each side of those two squares is equal to 3 units in its length. In the next step, we extended the radius GO by straight line until it touches side BC of rectangle ABCD at this point, point T. In this way, we created quadrangle TCGD. In this quadrangle TCDG, we have 1, 2, 3 rectangles, therefore the fourth angle must be equal to 90 degrees. So inside quadrangle GDTC, we have 4 rectangles, therefore we can relate to this quadrangle as a rectangle. And we know that the opposite sides of a rectangle are equal to each other, that is to say GD equals to TC, but GD is 3, therefore TC must be also equal to 3 units in its length. And then in quadrangle, in rectangle GDTC, side DC must be equal to side GT. But DC is 24, therefore GT must be also equal, here DC is 7, therefore GT must be also equal to 7 units in its length, and GT equals to 7 units in its length. Okay. So actually, in the next step, we extended the radius NP by straight line until it touches side DC of rectangle ABCD at point H. In this way, we created quadrangle NBCH. Inside this quadrangle NBCH, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. So inside quadrangle NBHC, we have 4 right angles. Therefore, quadrangle NBHC is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, NB equals to HC, but NB is 3, therefore HC must be also equal to 3 units in its length. Likewise, according to the same rule, side BC equals to side NH. but BC is 24, therefore an edge must be also equal to 24 units in its length. Okay, so here this angle equals to 90 degrees, therefore the missing angle here must be also equal to 90 degrees according to rule number 2. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees. Here we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees. So this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees, therefore we can conclude from it that quadrangle QKYH, that has 4 right angles, is a rectangle. Therefore side KH equals to side QY. But KH equals to 1 unit, therefore QY also equals to 1 unit. And here in rectangle YH TC, the opposite sides are equal to each other, but TC equals to 3 units, therefore YH must be also equal to 3 units. And we have already found out that NBCH is a rectangle, and we know that the opposite sides of the rectangle are equal to each other. That is to say, BC equals to NH, BC is 24, therefore NH is also 24. NH is 24, so NH minus NY minus NP in total must be equal to the missing side, side PY. So PY equals to NH that is 24 minus YH that is 3 minus NP that is 3. So in total, MY equals to 24 minus 6, that is 18. So we found out that PY equals to 18 units in length, QY equals to 1 unit. So here, this angle equals to 90 degrees because quadrangle QYHK is a rectangle. So if you focus on the upper side of the straight line NH at point Y, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees according to rule number 2. And because of the fact that angle QYP equals to 90 degrees, it means that the green triangle QYP is a right triangle. So I copy the right triangle QYP in a new page and we implemented the Pythagoras theorem on this green right triangle QYP. This is the right triangle QYP that I copied from the original drawing. We have already found out that PY equals to 18 units in strength, QY equals to 1 unit in strength, and this angle equals to 90 degrees. So we can implement here the Pythagoras theorem. According to the Pythagoras theorem, QP square equals to QY square plus PY square. So PQ square, that is the square of the hypotenuse, equals to QY square. QY is 1, therefore QY square is 1 square, that is 1, plus PY square. PY is 18, therefore PY square is 18 square, that is 324. So in conclusion, we found out that PQ square equals to 324 plus 1, that is 325. We took a root out of this equation and found out that PQ equals to the square root of 325. But 325 is 25 times 13. Then we took 25 out of the root. The square root of 25 is 5. So in total this expression equals to 5. And inside the root we left only with 13. So we found out that the distance between the centers of those circles, that is to say the length of this line segment QP equals to either 5 times square root of 13 units, or in terms of numbers, the distance QP equals to 18.03 units. Okay, thank you very much.